No, I know.
Thanks.
Yeah.
Good morning, ladies and gentlemen. I want to welcome you to our session this morning, Data Services for the Future. And by the name is Robert Buwule, and I will be your session chair. We have quite a number of fantastic presentations. So since it's already 9, I'd like us to start. So that we keep time. Our first presenters today are going to be online. Maybe let me first the first presentation this morning is Start at the Source. It's a collaborative paper by 3 presenters from the University of British Columbia. This is a Marjorie. I would like to introduce to you Marjorie Mitchell. Is the Copyright Scholarly Communications and Research Data Management Librarian at the University of British Columbia, Okanagan campus. She worked on the collaboration among a selected group of Canadian universities that investigated the RDM practices of researchers across all disciplines. Marjorie continues to develop training materials to support researchers at all levels of experience to better manage their research data. Additionally, she sits as a member of the Digital Research Alliance of Canada Research Expert Intelligence Group. Marjorie, together with Mathew Vis-Dunbar, is the Data and the Digital Scholarship Librarian with the University of British Columbia's Okanagan campus. In this role, he works with colleagues and faculty to enhance data literacies and provide training to better manage and connect one's research data. Mathew is also part of ongoing open science initiatives at UBC to promote research transparency and reproducibility, in part through better research data management practices. The third is Nick Rochlin, who is the research data management specialist with UBC Advanced Research Computing, where he assists researchers in all aspects of managing research data, as well as assessing and using high-performance computing infrastructure. Nick also co-chairs the Digital Research Alliance of Canada RDM National Training Expert Group, where he works with a network of RDM professionals to build and coordinate national training initiatives. So, Nick, Mathew, and Marjorie, you're welcome to present your paper this morning. You have 15 minutes. Please share your screen.
That kind introduction. So the theme of the conference is data by design, and where does design begin except at the source? And so we've entitled our paper Start at the Source, and the three of us will be collaboratively presenting this. Next slide, please. So this is a map of British
Hang on, we
Columbia.
can't hear you, Marjorie.
Is this better? I do have my mic turned on.
Steve, can you go grab a tablet?
Can people in
Can you grab
the
tablet? We can't. Sorry, we can't hear you in the room. It's not.
Marjorie, can you hear me?
Yes, I can.
Yeah, so apparently virtually everybody online can hear. It's just I think in the auditorium you can't hear.
Oh,
Oh,
there we go. Yeah, the other thing. Sorry, can you say something, Marjorie? Is it
Testing
Marjorie?
1, 2, 3.
Nope, still having trouble. Sorry. Sorry, Olaf. How do we get the audio up? Yeah, the map. Yeah, yes, we need to bring it up.
Testing, testing.
She's unmuted. Yeah, so she's unmuted. Yeah. We just can't hear it through the audio. Yeah, okay.
Testing, testing.
Okay, so keep making sound.
Testing, testing.
Yes, I can hear it in the live session. So there's something wrong.
The audio doesn't go here to the speakers. No, ljudet kommer inte från här till högtalarna.
Hello, hello.
Ja. Vilket ljudkort ska vara valt som utkälla här? Kolla om dataljudet finns. Vilket då är det? Var det på? Det var det. Could you try again?
Testing 1, 2, 3.
No,
I hear on the live stream is on.
it's not on your side. Testa ljudet på datorn. Inget ljud. Jag hade ljud förut. Yeah. Washing machine, what does it really? That's one way. So, now you know.
Men nu stängde du ner sektionen? Jag stängde inte ner den. Okej.
Try the sound again. Try the sound again, please.
Testing, testing.
Det går ju från datorn.
I have to do some research. Sorry, but I have to rejoin.
Yeah, people stop.
Jag får ta det som vecka.
Get it for.
Keep making sounds.
Testing, testing.
Yes, all right.
Good.
Oh, we have sound?
Yeah, you can hear you now.
Excellent. That's wonderful to hear.
Ja, de har externa skärmar.
So,
Am I free to go ahead now?
I think so. Got an annoying overlay here. Okay. Yeah, I think it's all right now.
Okay. Nick, maybe we'll back up one slide and give the brief introduction again. So our presentation is entitled Start at the Source. It is both looking at the source of data and the source of good data management plans. And yes, fits nicely with the conference theme, data by design. Next slide, please. So this is a map which you've all had an opportunity to have a very good look at, of British Columbia, and it outlines the Indigenous peoples of British Columbia. UBC Okanagan is located on the Silks Okanagan peoples territory, their traditional, ancestral, and unceded territory. And we are fortunate to live, work, and play as uninvited settler guests on this land. It is also, if you will notice, about 400 kilometers from our main campus in Vancouver, BC, along the coast. Next slide, please. Funding for our project has been provided by the Digital Research Alliance of Canada. Now, another reason that I want you to know that our project is funded is because we received the funding for this project after we had submitted our abstract to IASSIST for this presentation. So we had a project in mind and we're working on it prior to receiving funding. The receipt of the funding has done two things for us. First of all, it's changed our timeline and therefore changed the place that we're at now that we are presenting to you, but it has also allowed us to enrich and go through a better process, I think, in developing the resource that we're going to be talking to you about right now. Next slide, please. And this is a lovely drone photograph of our campus. It's a small campus. We can walk from side to side on it in just over 10 minutes. It's quite a pleasure to work there. Next slide, please. I want to give a little bit of context because we are quite different than the main campus of the University of British Columbia. We were established in 2005 as a separate campus. We are, as I say, about 400 kilometers from the main campus. We currently have about 12,000 FTE students, of whom 1,100 are graduate students. We have 664 faculty across 85 programs and disciplines. And annually, we receive approximately $4 million in grant-funded research. Next slide, please. The tri-agency federal funding bodies of Canada, which are made up of NSERC, the Natural Sciences and Engineering Research Council, SSHRC, the Social Sciences and Humanities Research Council, and CIHR, the Health Research Council, make up the tri-agencies. In 2015, they announced their first step in this process of managing or having requirements around the grants that they award. First with the open access policy on publications. The second step they took was a statement of principles on data management. And we've been waiting since 2016 to find out when these would be fully implemented and come into effect. And just this spring, in 2022, they announced a few pilot grants on which the research data management plan requirements were going to be implemented. So this gives you a picture of our landscape. We are behind the US, the UK, and Europe in requirements for research data management planning from our researchers. Next slide, please. This is over to my colleague, Mathew.
Awesome. Thanks, Marjorie, for that introduction. So I think really kind of like when we're looking at this project, one of the things that we were thinking within kind of like this scope of looking at what's happening at UBC Okanagan and what's happening federally from the funding agencies in terms of asking individuals to start to have data management plans and actually do something with their data when they receive those federal funds. We were really kind of thinking about, and we started this last year, in terms of thinking about the kinds of questions that we get from people when they are coming to us with their RDM needs. And we have a lot of resources available to us. We have resources which are developed by institutions in Canada. We have resources which are developed by federal bodies. We have resources that we heavily lean on, which are produced by international organizations as well, for how to manage research data management. And one of the things that we were identifying when people were asking us questions was really kind of like this divide, especially amongst new researchers. So really kind of looking at like graduate students and the cohorts that they're working with, and struggling to be able to integrate these principled or these generic documents, or these documents that were not designed for their specific disciplines, to integrate those in with their specific workflows and to be able to translate a lot of those documents over. If we go to the next slide, please, Nick. So what we really wanted to do was to look at how could we address taking this content that exists out there, this brilliant content around how to manage your research data, and make it accessible to bringing people into the graduate lab in an academic setting. So what we wanted to look at trying to do, one of the things that we first started with was building this kind of like this generic handbook, a handbook that addressed a number of base principle aspects of research data management. And then working with a number of faculty and working with a number of graduate students to look at building that content out in a way that was truly interdisciplinary. So broaden perspectives from a number of different disciplines that have very different concepts and understandings of what data is in the way that they do their research, and how that data should be preserved, how that data should be maintained. And then specifically working with those graduate students to really kind of track and record and document their learning curve as they go from individuals who are just beginning their research careers and being faced with these requirements to think about more than just a research output, but all the content that goes into that research. And then having these students work directly with the faculty partners that we're working with to take what is in that generic handbook that they've helped to build out, and to address specific issues and specific pain points that their faculty and their labs are working with, and to really kind of feed and adapt that content over. And again, to track that process so that we have an example of something which is rather agnostic and truly something which can be moved between disciplines, but a set of specific use cases and documented use cases of how those principles are taken and moved into specific applications within the lab. We can go to the next slide, and at this point, I'm going to pass off to Nick to talk a little bit more about the partners that we're working with as we go through this.
Yes, thanks so much, Matthew. And now that we have some money, we were able to hire graduate students. But looking at the full roster of our team, we have Mathew and Marjorie representing the library. We have myself representing advanced research computing. And then this yellowy color are our faculty partners. We have someone who's into visual anthropology, someone who's doing conservation and ecology, someone who's doing the digital humanities, as well as integrated knowledge translation. Now, in addition to these, we have 2 graduate students who were placed on the grant. They were doing desktop and cultural ecology respectively. So one that's very computational ecology and one that's working with Indigenous communities. But we've also hired 5 other students within these respective labs. So we've kind of built up this little army of students to help us accomplish these tasks. And so looking at the timeline that we have now that we have some funding, we've spent the past month and a bit onboarding these students, giving them base level training for what they can expect with RDM, some of the software and tools that we're going to be using during this project, and really giving them the skill sets and tools to go forward and start doing some work on their own. In the past couple of weeks, we've given them the handbook that we've developed that Mathew was referring to, and started getting them to, sanity check it, looking at each respective chapter and seeing, is this the content that you would expect to see based on what you understand from RDM and what's going on in your lab? And have we missed anything? Do we need more chapters? Do they need to be condensed? And then after this process is done, which we're aiming for by the end of June, we're going for that lab implementation. And so students will lead a RDM workshop for each of their labs, and that'll initiate a discussion about the pain points for data in their workflows in their specific labs. And after some back and forth, it's, okay, let's pick a specific pain point and tease it out, really articulate what this could look like in the practical implementation, and document all these processes. There's a lot of choices that can be made in these, and explaining why certain choices were made can be really helpful as a reusable resource for people to see as an exemplar. And so looking at these deliverables, I'm actually going to jump out of my screen share so you can see what this handbook looks like in its current state. And being very clear, and I'm dropping in the chat for those that are online, this is very much a draft, but from the outline, you can see that we have a number of different chapters here, and the outline goes over them. If you were to jump in one, let's say directory structure, you have a number of different sub-chapters there, and some of these are unique to these chapters, but at the bottom, we always have roles and responsibilities and questions. And these are really informing what practical implementation would look like, because in order to actually do this, you need to delineate these roles and have very clear understandings who's going to do what at which point throughout the process, and some questions to help guide those. And with that said, I'm going to jump back in slideshow. Boom. Now, in addition to that, for all of the other resources that we will be sharing, everything is an open educational resource. All of the slide decks that the students will be producing are going to be openly shared, and the concrete implementations that are used as manuals in their lab will be built into the handbook. Another thing that we're considering a deliverable is this student data champion. You know, students are the future of research and research ecosystems, and a lot of them are lighting up as they start talking about these concepts, and we'll take these on to future practices. And then the last one is faculty advocates and knowledge exchange. And not only are the faculty going to advocate for this type of work and be data champions in and of themselves, but as people working in research support, we're learning a lot throughout this process from the faculty and from the student about these specific workflows to these disciplines. And I think a lot of people, especially in Canada, I can't speak for Europe or other nations, but disciplinary knowledge is kind of an area that we need to improve on when it comes to RDM. And so this is something that we're aiming to build with this project. And then I'll pass it back to Marjorie to take us home. Oh, you are muted.
I muted myself, and putting this presentation together has given us a little bit of an opportunity to reflect, because quite honestly, since the call for funding came out in January, it has been a whirlwind, and it just was very nice to kind of collect our thoughts. So the first, and some of these are so obvious, but it's also good to note them, that high performing researchers are hard to schedule. One of our challenges has been getting 4 researchers from different disciplines all in the same room at the same time. Pluses and minuses there. The second thing we've kind of realized is that our plan is doable, which is fabulous, but it is also quite idealistic. As I say, when we sat down to take a breath and reflect on where we were, lo and behold, we discovered that we were on schedule. Surprise, surprise. Flexibility is absolutely crucial to the plan and the output, and working with the students it's interesting. They come at things from quite a black and white. Oh, you said the deadline was going to be this, and when we make a slight adjustment to it, it's not that they're unhappy with the adjustment, just that they aren't expecting this. So bringing them into work with a group and as a group is a new learning situation for them. So again, our flexibility, their flexibility is very important. OER, an open educational resource, really is the basis, the foundation for sustainability for this project. Once we have the handbook finished and the accompanying materials nicely packaged and ready to go, it really truly is our desire that people anywhere who find the materials useful can take them, adapt them to their specific local situation, their specific lab. We certainly haven't covered off all of the disciplines. We picked 4 because that was something we could manage. But I think, again, the basis and looking at the examples that we have provided will allow other people to pick up these materials and make them their own. with high-performing researchers come absolutely amazing students. I don't think I'll be telling a tale here if I said that Nick, Matthew, and I comment daily on how fabulous it is to be working with these keen, bright, dedicated students. And finally, I say we've become better at leveraging good tools and services of a project. And I mostly mean that I've become much better. Nick and Matthew, once again, were leading our pack in the ability to pull together using the open science framework and writing things in Markdown and all of these things. But I too am learning those skills. And with that, I believe I pass it back to, well, that's our reflections, I think. And are we taking questions at the end?
Yeah, thank you very much, Marjorie and Mathew, for that insightful talk. Thank you for that round of applause. We are really doing badly with time. Maybe I can receive only one question. If we set time at the end of the session, maybe we should have more questions. Is there any person here with a question or online?
Well, thank you for your presentation and being out at such a late hour in DC. Really appreciate it. My question is, how are you measuring the learning curve you mentioned as part of your project, and how are you documenting?
Are you referring to the our learning curve, or the students' learning curves, or the faculty learning curve? Because I think those are actually, they're all related, but they are rather different and occurring in different arenas.
I was thinking more of the student learning curve.
Nick or Matthew, jump on in.
In terms of the student learning curve, these students are fantastic. A lot of it was just aligning the onboarding and giving them the tools and giving them online readings. And I think they see this as fundamentally different than we do. And working in research support, we see this from a perspective of enabling research. They just see it as doing research with some new practices to help them organize themselves and to really contribute to this new thing and to build marketable and meaningful skills. So I think the motivation is really there. And you know that this is still fairly early on. So this is a very preliminary answer, but that's my initial impression. I don't know if Matthew or Marjorie, you have something to add to that.
Yeah, I think one of the interesting things for me is that because we really think about this, like Nick said, we think about this as research data management, whereas they think about it as the work that they need to do. One of the things that we're really trying to reconcile as we go through, as we think about the learning curves that the students are going through and how that reflection comes back onto us, is thinking about, because we really kind of, we get into using jargon, we get into using systems that are very familiar to ourselves, but are not necessarily very familiar to the individuals who have just completed an undergraduate degree, but are being expected to have certain competencies from their faculty and from the funders that they're working with. And so one of the things that we're really trying to do is, it's more about the conversation in terms of how we understand what these processes are and the language that we use to be able to communicate that, so that when we look at putting together the resources like the handbook, that handbook is articulated in a way that is not designed to be read by somebody who is a service provider for research data services, but by somebody who's trying to learn and to implement in the work that they do.
Wow. Yeah, thank you very much. Like I said, we should let the conversation continue. If you have more time at the end of the session, we shall entertain more questions, but I'd like to invite our second presenter. But we have Uber. We shall also have that. We shall continue with that. Sorry, we shall continue with the conversation on Uber. So, thank you very much again, Nick, Mathew, and Marjorie. Our second presenter this morning is none other than Jeremy Azzopardi. Let me hope I've pronounced it very well. Thank you. Jeremy Azzopardi is a researcher, engineer working with research data management at Chalmers, University of Technology in Gothenburg. He enjoys being a jack of all trades in data management and trying and failing to keep up with the new happenings in the field. He enjoys spending time in nature and growing vegetables. He's going to present a paper, Chalmers e-commons, one gateway to multiple services. Jeremy, welcome.
Yeah, hi everybody. My name is Jeremy. I'm going to talk about Chalmers e-commerce today. A few words about Chalmers first. Chalmers is a technical institute located in Gothenburg, Sweden. And we conduct research on education and technology and natural science mainly. Yeah, including engineering and shipping and architecture and even automated driving and things like that. The university has about 10,000 students and 3,000 employees and has been around for a little while. I'm going to talk about what led to e-commerce before I describe what e-commerce is. So in 2019, Chalmers ordered a report to look at the data management and other infrastructures present at the university, and it found that the resources at Chalmers were very scattered. Every department had its own solution. Researchers had a hard time to locate these resources, including data management resources. These resources were being developed at different rates, adopting different technologies for the same needs. There was duplication of efforts and inefficiency present. And of course, they were having a slightly difficult time keeping up with the demand for data-related infrastructures, as well as with all the demands coming from outside, the legal, the funding demands, and so on. So this led to a rector's decision in 2019, with leading to a decision to set up Chalmers e-commerce as an infrastructure with the mandate to deliver integrated support to researchers within computation, simulation analysis, and data management. Now, this of course gave some advantages in terms of how planning could be done, how the infrastructure could be developed, how it could also catch potential collaborations with both internally at Chalmers and externally. And the idea is for Chalmers to be a single point of entry infrastructure so that its users don't need to look far. They just come to e-commerce. Of course, we need to also tell them about e-commerce, and that's an ongoing project as well. And here we collect existing infrastructures which cover research data management, artificial intelligence and machine learning, high performance computing, and data science services, as well as setting up new infrastructures in visualization, storage infrastructure for data, and the digital research engineers, which provide a sort of more hands-on service and among other things, research data management. And of course, it would also be a more well-defined partner in collaborations externally. And one important thing was that this infrastructure would be present to help researchers during the whole research data lifecycle. As a contact point externally, Chalmers is collaborating with SND, Research Data Alliance, EuroHPC, SNCC, SUNET, and EOSC, among others. And yeah, we're also acting as a liaison internally at Chalmers for other sort of functions like archival, external storage, data protection, and other services. So just looking quickly at the internal structure of e-commons, I'll just focus on the green bit. There's three general areas which I've already mentioned. There's the infrastructure, which isn't data management related mostly, so computation and AI/ML. There are the research engineers in the middle, acting as a support and sort of more focused point of how do you say insats in Swedish? Now I've lost the English word. Yeah, doing relevant work in, among other things, research data management. And then there's the Chalmers Data Office, which is the actual research data management node at Chalmers. I'll just read what I'm going to speak a bit more about the research data management part of this whole setup here. Another thing which I wanted to mention was that we also need to constantly keep the organization or the infrastructure up to date with regards to what researchers need. So we have also set up or are working on setting up areas of interest. One of these areas of interest is research data management. And what it does basically is that it's a way for us to try to build a community around research data management to both inform about what we're doing, but also to gain feedback. Now, looking at the actual research data management support at e-commons, we have librarians, we have staff, mostly IT, archivists, and a research engineer, which is me. And we provide support and all the usual research data management support areas that you could find at any research data management support unit. We're focusing a lot on data management plans right now. So to make it a little bit more messy, because until now it sounded very clean cut, there's e-commons in the middle with Chalmers Data Office acting as a sort of hub for this. The research engineer is working partly with Chalmers Data Office, and we're also collaborating with other infrastructures within and externally from Chalmers to have non-research data management e-commerce infrastructures like computation. There's also the external collaborations. A big step for us is trying to solve the storage. It's a challenge which is right now quite common in Sweden to try and solve storage for research data, and especially sensitive research data. This is something which is not ready from our end, but we have several pilots going on. I'll speak about this quickly later. A very messy workflow. One thing that we need to do in order for researchers to really have a single point of entry is to provide an integrated workflow. And this includes automating flow of information and data across different functions in this workflow. So our idea is that by using a project information system, the CRIS, CRIS, and the data management plan, which we use data stewardship wizard, we are working on automating the feed of information from that to research data management support, because once they fill the research data management plan, then we'll know what they need. And also it will flag what sort of needs there are for storage, data storage. And also in collaboration with S&D, move metadata and data directly to S&D's systems so that data can more easily be published without a lot of duplication and inputting metadata, inputting information, and so on. And the same thing can be done for archival, which is hopefully will be closely linked to our storage solutions. Yeah. So a few pilots which are going on. These are mainly linked. There's one flagship pilot which we're doing with SND and with the Royal Institute of Technology, KTH, in Stockholm, which is where we're working with this flow of metadata between different services. We're also working on project storage and long-term storage, which we'll hopefully manage to link with e-archival later on as well. So hopefully we'll be able to come back in a few years and tell you that we've managed to do all this work without any problems. Thank you.
Thank you, Jeremy, for that insightful talk. You have a question from here or online? At least one. Another round of applause. Our next presenter is Darren Bell.
It's all right. I'll just introduce myself. That's fine. Okay.
Okay.
Yeah, I'm aware we're running chronically short of time. Okay, so I'm actually going to compress this because we really wanted to do a demo of an actual real tool today. So imagine I've just gacked a fat line of cocaine and I'll speed through this. Okay, and then I'll hand over to Deirdre to do the more interesting stuff. Okay, so I'm not going to bother with the slides because, yeah, we've got colleagues from Australia who travel around the world, and I really want to hear about the CADRE platform as well. So essentially where we are at the moment in social sciences is that everything's about FAIR at the moment. We're talking about findability, accessibility, interoperability. We'll be more quiet about that because that's the harder thing to solve. Findability is kind of easy. You just need a catalogue, slap a PID on it. Accessibility, say something about the access statement. Okay, interoperability is the one that's actually boring yet difficult. So this is the thing that we stood back and said, how do we actually make data truly interoperable? Because at the moment, the conversation is dominated by a theme of interoperability, when really what most people are talking about is data exchange. Okay. Now, don't get me wrong, all of these things are really good. It's really good that you put your data in DDI. It's really good that you have identifiers. But really what we're talking about is data readability and data exchange. We're not talking about operability. Can we actually take data set A in the UK and data set B in Germany and collectively work on them with a number of deterministic operations and do things with them, okay? So we've been involved with a product called DDI-CDI, which is the latest, slightly experimental incarnation of DDI. And CDI stands for cross-domain integration. Now, everyone is massively excited at the moment about collective intelligence and cross-disciplinary that and multidisciplinary this. But getting this down from the policy one discussion level to actual real interoperable tools is really hard. Now, CDI doesn't solve all problems for all people, but it's the first standard I've seen that's an approach to be able to represent both wide data, long data, key value data, and multidimensional data. So that's the structural interoperability problem, because a lot of conversations at the moment as well are dominated by semantic interoperability. These things are important, but structural interoperability is important as well. So we built a tool and we said, as a researcher, rather than rocking up to the UK data archive and basically looking at what is an FTP site, here's a bunch of files, download the file to my desktop, work with it. What we could say, for all of this data, you can pick a couple of variables from this data set, a couple of variables from this data set, join them together, and for us to say, oh, hang on a minute, you realize this is a really sensitive variable. If you remove that, you can have the data now. If you want to keep it, you're going to have to apply for it. There's just no way around that. But what we're trying to do is give researchers more flexible choices based around metadata uplift using something called data privacy vocabulary, which is a very recent W3 standard as well. So I'm not going to bang on any further because I don't want to hog all the time. So I'm going to hand over to Deirdre to do a demo of what we call the data product builder tool. Okay, she'll talk you through some of that.
Okay, thank you, Darren. Good morning, everybody.
Let's see if we could find this. Right. Sorry, so where, how do I share? Sorry, can you, I need to share the screen. Can you show me where the share options? This screen. It's this one here I want to share. Please, yes, I want to share this particular screen.
Let's just go like this. Oh no. Oh, okay. Yeah, but it's gonna hide it from the audience. Let me share that. Let me try one more thing. Sorry, guys. Yeah, I'm gonna just do that. I don't have permission to do that. Can you drive that? Can you see that?
Yes, I can. Okay, so I'm going to have to drive it from this screen. Can I make it a little bigger?
Yeah, just come back to me. Sorry.
Okay, so bear with me. Okay, so what we're doing with this proof of concept is trying to see whether we can harness cloud serverless architectures, in particular AWS DynamoDB, to serve DDI-CDI graph containing both metadata and macrodata. So in this case, we've loaded 5 data sets. So you can see here we've loaded 2 waves of the Understanding Society teaching data sets 8 and 9. We've also loaded the teaching time diaries, the Understanding Society time diaries. In this case, this is completely synthesized data, as normally it would be sensitive. And also we've loaded 2 open data sets, the index of multiple deprivation and open green space. And you see over on the left-hand side, we've got the else concepts. So variable level concept tagging allows us to drive the selection of data sets along with some geo tagging and some temporal tagging. So let's go ahead and say this researcher would like to work with health data. Let's choose health. So we can see that the 2 waves of Understanding Society have variables which contain health. And we can also choose geography. So let's choose England and year, let's just narrow it down to the year 2019. At this in this particular case, we're left with just 1 data set. So let's choose that. And now we're presented with the potential linkages.
Here we're utilizing DDI-CDI variable cascade, which is also available in DDI lifecycle. In particular, we're using the represented variable. So data sets which share a represented variable with the primary data set are presented as possible linkages. So you can see here we've got the index of multiple deprivation linked on LSOA, a UK census area, open green space linked on postcode, and both the understanding society wave 8 and the time diaries linked on the person identifier. Now, those of you who are more familiar with the understanding society teaching set will know that it doesn't have LSOA and postcode normally, but for this demonstration, we've synthesized some of that data and added it to show how we would work with sensitive data. So let's go ahead and link with the time diaries. Now, this is an example of a long data set. Darren talked about long data, the CDI's possibility of linking different types of data sets. So the primary data set is a standard rectangular study, so a wide data set, and we're linking with effectively events data with the time diaries. Time diaries here, they're roughly about 30 activities per respondent. So let's link with that. And then we're presented with the measure components. So in CDI, we can have variables to tag as either identifier, attribute, or measure. We allow filtering on measure variables. And I just want to point out here a little bit about our enhanced ingestion. So here you can see that Darren talked about Cpv tagging. So as well as semantic tagging with else concepts, each variable is tagged with privacy concept from the Cpv vocabulary. So you can see here that both the postcode and the LSOA are deemed sensitive and therefore not available for filtering. And also as part of this enhanced ingestion, where only fine-grained geographies are available, we go up the geography hierarchy and add the next level. In this case, we've added local authority. So let's go back up. Now, let's say this researcher is aware that the GOR, the government office region, is available, so we can filter on that. Okay. I'll put my spelling on. Okay, so let's choose that normal variable. And let's say this researcher is interested in people in the east of England. Oh, one thing before I click on that, I want to talk about our data, the idea here of our data-driven research as against metadata-driven. So before I click that, the count was at around about 176,000. So we're using another service architecture. We're using elastic compute to do the counts over the microdata dynamically in the background. So the joint data set would have around about 176,000 records. Once we filter, it immediately recognizes that we're now down to 17,000. So researchers don't need to get, don't need to apply for data. It maybe takes 3 months and then suddenly discover it doesn't contain anything, any of the data they actually want, or the data maybe is in a slightly different format. This allows them to explore the data before they actually get it. So let's go a little further and let's filter a little further. So let's get rid of that. And let's search. So let's take a scalar variable. Let's take age. And let's say that this researcher is interested in people in filtering on age. Now, what we've done is you can see that the case count is quite responsive. And once we go over a certain number, we're down below 100. At this point, you can see you can no longer proceed. We don't allow filtering below 100. Now, let's go back and take it down to, let's say, about 65.
So the researcher is interested in people in the east of England on or over the age of 65, and let's proceed with that. Now, all the variables identify our attribute and measure a variable for output. If we choose all of them, immediately we see that we're prompted to say we've selected sensitive variables. If you were to proceed to the next stage, the preview stage, it would show you the first 10 rows, but it would perturb the sensitive variables. And once you proceed to stage 6, it wouldn't allow you to download the data, but it would redirect you to the UKDS website to apply for the data. Also, what we intend to do with this is to bundle up the query syntax so the access people are aware of exactly what's being applied for. But in this case, let's say this researcher isn't particularly interested in low-level geographies, so he removes them. And you can see he can now proceed. Now what's happening is again, we're utilizing elastic compute. So it's going over the full joined data set to present us with the first 10 rows. So in this case, we have I think the wave 9 is around about 13,000, and each of those has an average about 30 activities. So we move along to the right-hand side, we can see these activities listed and the duration of each activity, and we can proceed. And we're presented with the fields necessary to create a DOI for our data product. So let's fill that in. So let's say I won't waste time doing too much of this. Okay, so let's continue. Now you'll see that it's gone out to the DOI data site. In this case, it's the test data site, and it's created the DOI, and this data set is now available for immediate download. I won't click on it here, but if you were to click on that, if you download a CSV with the joined data set with the variables you want, and you can work away with it. Now I'll hand over to Darren to talk about where we want to take this going forward.
Okay, so I'll wrap up very quickly. What I would say is that what we're trying to do here is solve the problem of access, because it's a completely unsolved problem at the moment. Interoperability is never going to happen until we can do machine actionable access and algorithms to do real-time disclosure risk assessment. If you are interested in those topics and you want to do some real work over the next year or two around this topic, please do contact me. Okay, it's dbell@ESSEC UK, and I'd love to hear from you, because I don't think EOSC and FAIR at all attacking this problem or really ever going to solve it in the next 5 years. So if you're interested and you want to do some work, yeah, get in touch. Okay, thanks.
Yeah, thank you again, Darren and Deirdre, for that wonderful talk on DDI and DCI. Is there a quick question?
Here. My question is that how dependent are you on statements of the metadata for this attribute? So when you're selecting data to go in, how much do you have to generate appropriate metadata to make that system work? because of the usage of a number of things that I learned through.
Yeah, all of this depends on metadata development. And one of the reasons I don't think EDSC is working at the moment is really all the data, how much work actually needs to be done at the source metadata to make anything useful happen. So switchboards and other SPSS that's at least sort of what we're keeping change nothing. So yeah, I'm really conscious of
Thank you very much. Yeah. Our next presenter is none other than Rob Grimm is going to present a paper titled EDSC 15 Years of Economic and Financial Data Support, Data Stories, Lessons Learned, and the Road Ahead. Rob Grimm. Okay. Interest of time.
Yeah. That's good. Let's see, I feel some time pressure, like everyone else I think for this session. Where's, we have a mouse to start with. On my screen. All right. Okay. Can I close this? No, I can't close this, right? Can I minimize this? 'Cause I know where my presentation is. I just want to start from the. That's fine. Next month, then I'm good to go. All right. Yep. Yep. Already.
You start talking. No, like they're not screenshot. No, people online chance. So you can start talking.
Start. Yeah, but people online can't see it, but it's off the business. Yeah. Okay, thanks. All right. Yeah, I better get started, right? Hello, everyone, also online. My name is Rob Grimm. I work at the Erasmus University Rotterdam with the EDSC, Erasmus Data Service Center. And first, I want to thanks to the conference organizers and the reviewing committee for having me. Right, Gothenburg, I learned was founded by the Dutch this week from the deputy mayor of Gothenburg. And this is a picture from Rotterdam, where my university is located. And Rotterdam, like Gothenburg, is closely linked with its seaport. Here are some of the typical houses Rotterdam is known for, with Erasmus, famous scholar, 15th, 16th century. And this is our team. My colleagues, and this presentation would not have been possible without my colleagues. Yeah. Okay. Well, since I also want to cover quite some ground in 15 minutes, which I listed in this overview, and before I dive into this, is there anyone working actually with financial data? I know that within IASSIST, small communities, people from Princeton, but I don't expect too many people working with financial data. Is there anyone working with financial data? Could you please raise his or her hand? None, as I expected. Presentation is still of interest because it's a lot about metadata, and in contrast to what Darren said, I think the findability issues are not solved at all. I'll come to that in a minute, right? That's a point for discussion. Okay, just a brief overview of our services. We do individual support, we have workshops, we do question handling, we have a Bloomberg class, we have virtual machines for remote access for students, and we do budget and holdings management and a few other things. And yeah, we do also ad hoc support, like for example, Google BigQuery. Actually, we'll go back. The picture on the right is the office building where we work, which is really a great place to work. Okay, what are today's challenges for us for economics, business, and financial data support? So we have more students. We have 15K economics, business, and finance students alone in 2020, and we see growing data demands, volumes, availability, variety of data, and we see further data monetization. Data is the new gold, and I think some vendors take that too little or too little. When I see some of the price quotes, in addition, we see demand for use case support for big data and data science applications. The picture on the right gives captures very well, I think, the a number of topics that are core to the EDSC services. Then some highlights from the EDSC. We were founded in 2006 in demand of the faculty, and the data team was since then run by my colleague Paul Plaatsman, who is also a regular IASSIST visitor. Core foundational principles. So can the library set up a data support service for economics, finance, and business students, as many of them encounter difficulties in finding and using data for assignments and thesis, and they're also having difficulties in using specialized finance databases. And also, can the library help us in creating a database portfolio that supports research, that supports our research community, and which will be recognized as a true asset of our university. Right. Well, to briefly, one more recent highlight through the relevance of providing remote access to one of our most used resources. I have to go back to 2020 when, during lockdown, the EDSC data team had to take over all student data gatherings from data stream, but there was no on-site access available. And right, this has luckily changed by 2022, where the trained eye can see from this picture that the self-service is being taken up again by students. And well, okay, having said all this, the whole idea behind this presentation is that the library brands itself as the content manager of the university. And with this remit, we keep asking ourselves how to put this service concept into practice and where can we do better. What you see is a slide on the usage of WRDS data, one of our most used sources. WRDS is a platform on which a substantial number of our licensed data products are hosted. And the panel on the top illustrates the usage of some 20 WRDS data products we provide access to. All these data products typically consist of several data sets, each with a good number of variables. We have 100+ other data sets as well. So how does the user find out what is available in these various data products, right? The panel below shows the top 5 web queries and data extracted. These are all 6-digit figures, millions of queries run for CompuStat, CRISP, and Eventus. And the point of this figure is that financial data is demanded for and used in large volumes. And this is the data is for research stuff. It's exclusive. Students are excluded from these figures. Okay, and here's another example of Thomson 1 available through the Internet Explorer, which will, yes, retire in 5 days. I need to go back, sorry. Right, so you see a typical example of an information-dense interface here with many underlying settings for the various data topics covered by the application. And here we see the top 100 sources used in Factiva in 2020, presented as 2 variants. And note there are 6,178 resources in Factiva. That's one source of the many hundreds of which we have. And of these 6,000 plus resources, only 1,666 were used, accessed, or searched for at least once. And these internal resources are very difficult to find for users. They're not well indexed in the search engine. And if you don't have this previous domain expertise, you'll never find it. Here's another example on ESG, environmental social government topics. Data is very much, there's a high demand for this among students and research staff. Very popular topic. And these items are very difficult to find across databases unless you know already where to go. So the question we ask ourselves is, how can we capture this information, verify this, if you will, curate this in such a way that the information is delivered to the user in a meaningful way? And this might look and feel like an obvious no-brainer, as I heard in the previous speaker, so to spell this out to this community. But I think search and discovery is still an area where substantial improvement are needed. And especially in the field where we are in, it is difficult to leverage metadata from disparate sources for granular discovery, data retrieval, and satisfying UX experience for the user. Yeah, I could go over each of these individual bullet points, but in the interest of time, and I'll continue. Yeah. Okay. So my talk is about extra investing in discovery, curation, and data delivery. That's the main takeaway from this whole talk. But now a few words on curation. So why curation is relevant for business and finance data. One thing that struck me not that long ago is that, for example, Pinterest advocates itself as a platform for visual curation, where people you and I can categorize content by grouping pictures, and where statistical clustering techniques are used for automated curation. And no, this is not my interpretation. These are the words from Yuri Leskovich, which is the chief data scientist of Pinterest. I promised myself to speak slowly, so I should try to do it. I listed several arguments for why curation is relevant for business and finance data, and it's worth to name a few of these. Right, so key is here that are few academic finance reference data sets. And I'd like, if anyone does disagree, I'm first who wants to know it. So that's in contrast to many other social science sources and the impact on the real economy of all the economic databases. There are little academic curated, high valued reference data sets, which is surprising. And the heart of the matter for curation for our field is simply twofold, though. So we need more quality data sets and we need more linked data sets, right? Yeah. Okay, then the third pillar, so to say, is all to deal with data access and delivery, and that's where I'm on the same page with Darren again. We need to bring the user to the data. That's my yeah, I'm sure that's a road to go. And yeah, you see here various arguments. One thing that is worth, I think, mentioning is and it's related to open science and transparency and reproducibility, is that with one argument to bring people to the researchers to the cloud is that you can allow for creation and ownership of derived works without having to hand over and distribute data, which is relevant for finance applications, as we use often commercial data, which is not allowed to share further. And I've seen already applications where this is possible, and this is also of interest, I think, to our data team. If you have any questions on that later, contact me in the break. While writing this disclaimer note, we do ourselves do not have this data platform yet, but we know where we want to go and we know how to get there, so that that's already very important, I think. Right, and the picture below is an interactive map of all questions that we got and through the last 10 years, and which is one of the analytics we did on the data. Well, here's a sort of recipe of how to put everything together, and I use MATLAB and the MATLAB text analytics toolbox for metadata management and data structures. We don't have a large team. And I simply use a bag of metadata where I put everything I can get into one file structure. And then the metadata capture consists of combined manual work, simple copy and paste work, codebook conversions, question analysis. I extract FIBO, that's the financial industry business ontology concept, whatever data I can scrape. Copy paste, etc., into some data format so I have a huge text-based corpus, and then structure that, right? And then the other element is for capture. So we're going to add real data to that. So the curated topical data sets, like we make data sets for ESG, sort of we make a package for the students that are interested in that. We make packages for specs and sort of the topic of today, the topic of that the students have interest in. And these are downloaded or these are sent to students or but in the future, so we want to move them to a more platform. Right, so we have various curated topical data sets. We can technically augment the data with user statistics and cost information so that use the metadata as feature factors where I add user statistics or budget holdings information to and use that as weight factors to analyze the data and feedback into the discovery front end with respect to the relevance of the data that should be presented to the end user. Okay, and we use various other analytics techniques or n-gram techniques, latent dirichlet allocation techniques, and clustering techniques. And so the third layer is the data access and delivery, which is really critical, I think, for future services. And that would consist of a data catalog, of which we published already version 1, which holds sort of a high-level overview of all the data sets that we have and are of interest to the economics researchers within the Rotterdam School of Management. On-demand delivery will continue, definitely. But the next thing we will be doing is platform elaboration, like services like Darren was showing, or use Snowflake or various others that we are in contact with. And yeah, I'm happy to collaborate on the metadata management side if anyone would be interested in pushing this further. And if I have to explain this all to my mother, I use this simple dialogue screen. So this is a high-end overview of what it basically is. I have tons of sheets beyond this, but I think it's about creating a metadata catalog that eats from the databases. The curated data, they go back and forth to the metadata catalog. The metadata is pushed to the front end, the discovery, and the curated data should go into this cloud access delivery layer, and the databases also should go, some of them, into that cloud access delivery environment. And yes, there will be some continuation of downloads. Okay. Yes, please. All right. There it is. Yeah, and that was everything for me. Like we say, make it happen in Rotterdam. So, yeah, thank you very much. Any questions?
The first thing that because of time, we have
if you don't mind. So let me invite Stephen. Come and make our presenter for this session.
Please hold your questions. You shall ask at the very end of the session.
Okay. I have the advantage of I have the advantage of actually giving a presentation about what this project is about after the break too. So I'm just trying to figure in the interest of time. So I'm Steve McEachern. I'm director of the Australian Data Archive at Australian National University in Canberra, Australia. I'm going to talk a bit about this particular program we have called CADRE. As I say, if you want more details about the origins of it, I'll point you to the next presentation, which is in session H1. So I'm going to kind of skip over a few things here, but in the interest of time. This project is oriented around supporting the five, basically a practical implementation of the 5 stages framework. So, we've talked quite a lot about data security and data sensitivity and the like, and look at the plenaries. We've talked about sensitive data and sensitive data access and management. And actually, what we're trying to do is take the 5-stage model, which has been developed in some of these spaces, and say, how do you turn it from a risk management framework into something you can actually apply fundamentally? Can you use informatics basically to turn what is a set of principles and practices into some actual information exchange and decision support is really the core of this. It's not a data management platform, it's a data access and a coordination platform. So it's really about a story of metadata exchange, which is where the information framework and the focus of this particular presentation comes to. It brings together 3 broad types of groups. We have universities and archives. So these are all from the Australian context. Universities and archives, government agencies, and then e-research providers. So particularly in there, our National Research and Education Network, ARNet, our National Access Federation, the Australian Access Federation, and some of the other e-research providers as well. But particularly it brings together the different parts we think we need to kind of operate this system. I have to flash up a funding slide. So there it is. We get support from the federal government through the Australian Research Data Commons under the National Collaborative Research Infrastructure Strategy. So it is a part of our national infrastructure program. But what we're trying to do fundamentally is to establish, to take the 5 stages and say, okay, what are the information needs you've had there, and how might we manage that exchange effectively? So we started with a conceptual framework, and that'll be the basis of the next presentation. It's up on Zenodo. Basically, I outlined the conceptual underpinnings and the guardrails for sensitive data access management and the range of information we might need to support actually exchanging knowledge around 5-stage principles. So what we were trying to do, let's say, we established the conceptual framework. As I say, more after the break on that one. The information requirements we're really looking at is, well, what do we need to actually be able to exchange? Access requests and manage the requests and the access to sensitive data for search purposes, to be able to collate, synthesize, and visualize information for decision support. And I'll give our initial worked example of that. To be able to bring together multiple information sources about the 5 stages, people, project, data, settings, and outputs in a coordinated way, and to manage then that in the process of research workflows across multiple systems. Most of these things involve transfers across multiple providers, and we're actually using some of the work that occurred that Nicholas Blomberg was talking about on Wednesday. That's one of the frameworks we're using to look at that sort of movement across systems. We're not doing a lot of that, but that's the, setting up the foundations for that. Okay. So our first efforts, this is really, about fundamentally a graph. It's a graph model for exchange, that information exchange to collate and synthesize metadata. It's actually a metadata exchange platform, which this ends up being focused on. So what are the relevant standards we can use? What's existing work internationally that we can build off? And there's some work going on in the Research Triangle in North Carolina around trusted storage and interactions with things like Dataverse and remote storage systems, and a very nice piece of technology called CI Logon, which is coming out of Illinois. And then the data use ontology, which is actually coming out of the Elixir program that you heard about, and the research passport, actually, that the ICPSR and Maggie Levin's team have been working on as well as some of the nice things we're really trying to build upon there. And then related work occurring in Australia around secure settings. The secure research platform has been implemented in Australia. It's actually the technology that came out of the SAIL data bank in Wales that picked it up and put it there as well. So applications to the Australian context. Broadly speaking, we've got the sorts of sources we're able to draw upon. What we've learned, I mean, ADA has been doing this, this sort of work for 40 years now. So what are the things we need that actually go into the 5 SAFEs itself? What are the sorts of additions we might be considering around ethics, both in terms of training and accreditation? How do we draw upon content that's coming in and out of ethics systems? Trust and identity information coming from our access authorization and access provider, AAF, and then being able to leverage that and extend that into what we already know about people that's open and available. So we're actually engaging, connecting into the scholarly graph through the research graph community, which is actually an issue that's come out of the Research Data Alliance, to touch on there. So we have the information sources. Now we're looking then, well, how do we actually leverage that information to provide decision support? So that's fundamentally what some of the access management is all about. You have to make assessments on the quality and suitability of data access applications more effectively. So as I say, the sorts of knowledge we were drawing upon there, that, well, I say, what do we know about the sort of request, the project, and then a requestor, the safe person? Well, as I say, and here we're trying to take advantage of things that are already known about an individual and the sorts of projects they are. And so here we're trying to engage into the persistent identifier systems that are available to us. But also then be able to enhance that with internal knowledge that might be available through providers. So ADA keeps records, obviously, of our access. Similarly, that's going to be available with other providers as well. But we have fundamentally a model where we can fairly nicely map the persistent identifier system into the 5 SAFEs, which is a really useful thing to be able to start building out that research, that access graph. So DOI is nicely mapped to both data and potentially outputs. I'll say potentially there. ORCID's clearly mapped to people, and then we have sort of the access federation and the internal access controls that are there as well. And Researcher Passport's done a nice job of engaging there. Settings, we don't have a great identifier system for settings right now. How would you actually identify a particular constellation of tools and technologies that constitute a virtual lab, for example? So that's a bit of an interesting one to deal with, but we're working to there. And then the other one, and this has popped up in a couple of places, is, well, what about identifying projects? Well, we actually organise things fairly heavily around projects, but we don't really identify those all that well. There is an effort in Australia, though, to try to start articulate that. It's a system called RAID that's coming through the ARDC community. So we think we've started to build out the key things we might be able to connect to and start building out the graph effectively there. And so we've been able to sort of work through an information model. Don't worry about the specifics of what's on the screen. The point here is, we're basically getting into a relationship diagram here, which is clustering settings. Each of the 5 SAFEs are actually represented in there, plus a couple of extensions. There's two key things that we think we need to particularly build in. Better information about organisations and better information about groups. How do we actually structure and manage group access? Because people work in groups, data is collected together in groups, the sort of thing that Darren was just talking about. Very exciting stuff, which is fundamentally we're grouping data and variables effectively. And that's not particularly well represented. So that's where, I say we're particularly focusing some of our efforts there, but describing people, roles, and their interaction with organisations and other, critical tasks there as well. So we started to build up a prototype information graph. So building upon, say, public information through those persistent identifier systems, internal administrative information, and then thinking about all the privacy impact assessment that's going to go along with that is the next stage of how we're looking into there. As we start delving into non-public records, there are obviously very clear implications of that, and our government partners in particular, certainly focusing our efforts there. And then internal and external identity information as well, both internal institutional records, but also the way those records and systems actually connect into the Access Federation. So, as I say, we've been able to, early on, early successes here. We've got our trust and identity providers, AAF, working quite closely with us. And through AAF, we actually start engaging into potentially into international systems as well. So we do see international applications here. AAF is part of an international program called EduGain. So you can sort of potentially take this out into, national and international environments as well. So fundamentally, the technologies are there to be able to enable that if we can figure out the administrative and legislative arrangements. But here we're getting our authority attributes, names, affiliations, email addresses, and then enhancing that with other information we can build out through an application process. But part of what we want to do is progressively build out the things we don't know inside the graph. So as so you're potentially extending the graph that's there. The starting point of that is connecting ORCID to the systems, and AAF nicely is also the national coordinator for ORCID and tying it into those identity provision systems. And then we're using the CI logon, which is this sort of a foundation technology that's being provided for group management and access and identity management, and be able to connect across systems. And the Biocommons, which is the Australian implementation of Elixir, they're kind of our proof of concept for that, and we're working quite closely with them with that. So the premise here is, by working through that sort of core group and identity provision, CI logon service, by tagging, connecting into our identity providers, we can then be able to sort of feed our way both back and forth between some of the services that we might want to connect into, and that includes our own platform. So we're going to build a dashboard platform for CADRE, but also the systems of of our partner organisations, and potentially progressively into other systems. We're not engaging right now with remote labs and remote access services in that way, but that's clearly on our radar. There is also, interestingly, how do we get it past the fact that not all research actually happens in academia? It might happen somewhere else. To our government partners, what are those sorts of identity provision services that are there that we can draw upon there as well? And again, sort of, we have a related program happening in within our federal government to connect those sorts of services in as well, which includes us being able to use AAF to log into government services, which is very interesting for us going forward. Similarly, I say, and this is all about sort of building out different parts of the graph, we're also looking at, well, how do we use the scholarly profile to start building up what we can know about safe people as well, and potentially safe projects clearly comes along there as well. So what do we, by having ORCID, by having connections into Crossref and other systems, and we actually have to augment the knowledge we have about people and the sorts of work and the sorts of activities that they've been involved in, by information on the public record, to basically enhance and augment what we receive through an application process. Now, again, there's a question of sort of permissions and and privacy considerations that come with this, but we're thinking partly about how we manage that process. But we have built a prototype for that. This is coming from colleagues at Swinburne University and the Research Graph Foundation, to look at what we could even do just by enhancing what we know about our data sets in ADA, picking up a connection to the Dataverse API. So fundamentally, they've got this model. This is work that's, they say it has its origins actually in RDA. There's the Scullen Data and Publications Exchange. This takes this further. It's the same people working on that. Researchers, research data, organisations, grants and publications. Fundamentally, you've got a graph that's there. By basically taking what we know about people and data sets, we can progressively build out that graph effectively. So what we did is the Swinburne folks, they took the data sets that already exist, connected that to the researchers we know were involved in just collecting that data. So this is an experiment on who produced the data, not who's using it, but to demonstrate the concept there. Enhance that with ORCID information where we have it available, tied that then into the known grants and publication information and connection into their organisational records. And what we were able to do is, take note here of the greens, the reds, the oranges, and so forth, because by identifying the data sets and the researchers for the ORCIDs that we have in the system, on the left-hand side is the information we already had known available about people who produced data sets that are published in ADA. On the right-hand side is the enhanced information that we're able to draw upon, which is, here's the researchers, here's the publications they've produced, here's those organisational relationships that actually exist. So, progressively by traversing the scholarly graph, we can actually get quite a lot of information that we're able to bring together. You might say, well, geez, there are big privacy implications of that. But this is, if you're the person who's looking for access to data, probably what you're going to be wanting to do is to say, well, this is the sort of work I've done. This is the sort of things I'm involved in. Here's the projects I'm doing. Now, what if we can bring those in for you with your consent? Here's a means for actually traversing the graph to say, how do we streamline that process? And can I use that again in future? So it's progressively enhancing what we know to build out that graph effectively for the benefit of both the researcher and the custodian fundamentally. So what's coming next? Building out the graph itself, turning from the model to the implementation. So trying to build the platform for both the how we store that information, where it gets stored and by which partners and through which exchanges, and how do we build out the decision support platform. Developing the user interface itself, so it's user interface development, not developer, spelling mistake by me, and that's really going into the second half of this year, and then progressively extending that to be able to connect to services, and that includes, I've put ADA in there as well, but we are going to be a consumer of such a service as well. If we can leverage the information out of that graph, but also our colleagues within the Australian Urban Research Infrastructure Network, Swinburne, AAF, how do each of us take advantage of that information that's there to provide both a more streamlined exchange of information between service providers, but also a streamlined service for researchers who are able to take what we already know and use that information rather than having to type it in, reuse it, reproduce it every time again. And that's there's a virtuous circle both on both sides of the equation. So let's say the conceptual framework is out. The information model is we're building at the moment. You can certainly go on and have a look at the framework itself, and we'd encourage feedback. We really are keen to see this applicability locally and internationally. And say if you're interested in seeing more, well, say hopefully this time next year we'll be able to demonstrate the live system for you. I'll leave that.
Thank you very much for that. So, and now we're ready. Actually, very much, but I think I have some questions. So, why? Question from our
Yep.
Why is research data, which are mostly linked to CRD, raw, organizations, and data, not linked to donors?
Not linked with
Donors.
I get the rest of the question except for the very final word.
Funders.
With funders. It is grants. Okay, so there is grants within that model, but here's what they say. The important point of that is what's not in particularly our persistent identifier system is projects. So connecting, we can connect grants to people and sorry, let me go backwards there. The grants here, they are part of that, that ecosystem. Where that is the case, we would say ADA, we were using ADA's, information supply, services as sort of a foundation there. Where we have grant information, we put it in there. But again, it's what don't we know already? So how do you consistently build out the edges and nodes of the graph that you don't know? So where it was available, it's probably not particularly prominent there. there are items in yellow there, but they're very, not a lot of them. It's because we don't know them yet. What we're trying to do is then build out, and progressively, if we get that information in an application tied to a project, well, then we can feed that back into the system. So, as I say, by the process of managing the application process itself, we are able to feed the graph, and then not have to return to that next time.
Any more questions? How do you store it in
I think it's Node4j. From memory, I say that's our Swinburne team have been working. I think particularly, I think it's Node4j to manage that. And then the question, one of the interesting questions for us is not just how you store, but where you store it. So there are there's a big lot of information and potentially identifying information in here. So the next question is what's the environment and the space in which it's suitable to store it. Yeah.
Okay, the final round of applause for all our presenters. Thank you very much for those presenting talks. Thank you for joining. For this now.
Oh.
Yeah. Yeah, that's fine. I should be really keeping it.